Hello, my fellow physics students. Today we're doing music. For this project, we had to make an instrument. I made a guitar sort of thing, and I made it from my middle school art notebook and some hair ties and some binder clips. And there's a picture of me making it. So this is the instrument. Yeah, it doesn't look like much, but it works. So I'm gonna play each of the notes and show on screen the Tuner Ninja thing. Show what frequency these things are. So here's the lowest note. And here's the middle note. And here's the highest note. So as I showed you, how you play it is you plug the strings, and what's oscillating or what's moving is the string because you're plugging it, and that oscillation makes sound because you're essentially giving energy to the string, like kinetic energy, so it's moving, and that movement also pushes the air around, so that makes waves, sound waves, and those sound waves are what you hear from the instrument. So standing waves. What standing waves are is when two waves of the same frequency are going opposite directions, so they interfere with each other and make this new standing wave. And they influence sound because it's a wave. So there's sound waves, especially talking about fundamental frequency. That's the most prominent sound that you hear, because if the waves are interfering, of course there's multiple sounds. So the standing wave, that's the fundamental frequency, the thing you hear the most. And so that combination of those waves makes a pretty good sound. Alright, so let's talk about the notes. I already showed you before the frequencies of each of the notes, that top value being the bottom note. And so you can see the length here, it's corresponding to the list of the frequencies. So as you can see, the largest length corresponds to the greatest frequency and the lowest note. And the shortest length has the smallest frequency and the highest note. And so that proves that length does affect frequency, and you can see it in the equation that we use. Frequency equals the harmonic times wave speed divided by 2 times the length. So now I had to calculate the wave speed of one of the strings, and I did the highest note, the shortest length one. So you can see the numbers there, and I used the equation I mentioned. We know, of course, the frequency, the harmonic, the fundamental frequency, and the length, and you put those numbers in, you do the multiplication, and then you multiply each side by 0.15, and that's the velocity, about 41 meters per second. So to conclude, what I learned was how the fact that length is what affects things like wave speed, frequency, either one of those. And there were some challenges. I had to figure out how to get the strings to produce different sounds, so I did that by adjusting the length. I also had to figure out, the calculation So I use the equation for that using the frequency that we know and the length. Thanks for listening to my presentation.